Global supply chains look fragile. One delay, shelves go empty. One disruption, prices spike. So how do they stay stable at all? Because they do stay stable most of the time, even when chaos hits. Storms, wars, port clogs, factory shutdowns, and the network still moves. Stay with me, because the real answer is a hidden system. It's not one company, it's layers of backup, rules, and improvisation. First, the truth. Supply chains are not one chain. They're networks, thousands of suppliers, routes, warehouses, carriers, and contracts. And networks survive shocks better than straight lines. They can reroute and adapt. But only if they have control points. Otherwise, it's just chaos. A supply chain needs visibility. It needs tracking, planning, and priorities. If you can't see the network, you can't manage the network. So stability begins with information. Information turns panic into decisions. And decisions turn disruption into a manageable delay. So what keeps the system stable? The first answer is redundancy. Redundancy means more than one option. More suppliers, routes, carriers, or materials. It sounds wasteful, but it's how networks avoid single points of failure. Redundancy turns a crisis into inconvenience instead of collapse. Companies build redundancy in different ways. They qualify multiple suppliers for one component. They diversify countries and regions. They avoid relying on one factory. This isn't paranoia, it's survival engineering. Because one weak link can shut down an entire product line. The second stabilizer is buffers. A buffer is extra inventory, extra time, or extra capacity. Buffers look inefficient on spreadsheets. In real life, they're shock absorbers. They give you time to reroute, they give you room to breathe, and when disruptions hit, breathing room is everything. Now here's the trade-off. Modern business loves efficiency. That's why just-in-time became popular. Less inventory, lower storage, faster cash flow. But just-in-time assumes predictability. The world is not predictable. So just-in-time works until it doesn't. After every crisis, companies quietly add buffers back. They keep safety stock for critical parts. They reserve warehouse space. They build extra lead time into schedules. They don't always call it a buffer, but that's exactly what it is. A hidden cushion built after pain. The third stabilizer is standardization. Standards make switching possible. Standard containers, pallets, barcodes, documents, and shipping terms. If formats are compatible, you can change routes faster. You can change carriers faster. Standardization turns chaos into plug and play, at least partially. Think about shipping containers. They made global trade scalable, but they also made crisis response easier. A container can move ship to rail to truck without unpacking. That removes delay, it removes handling, it removes risk. Standards are boring, and that's why they work. The fourth stabilizer is forecasting and planning. Supply chains don't run on vibes. They run on demand forecasts, production plans, and replenishment cycles. When something breaks, planning becomes the control tower. It decides priority. It decides what gets made first. It decides what gets shipped first. This is where data matters. Companies track inventory, shipments, capacity, and delays. If you can see the network, you can steer it. If you can't, you can only react. Visibility reduces surprise. Surprise is what turns problems into disasters. So tracking is not a nice to have, it's stability infrastructure. Now here's the twist. Visibility isn't only technology, it's relationships. A supplier tells you the truth or they don't. A carrier updates you or they don't. A port shares congestion data or they don't. So supply chains run on trust. Human networks are part of the system. The fifth stabilizer is prioritization. When everything goes wrong, you can't save everything. So companies triage. They protect critical products first. They allocate scarce parts to high-impact items. They cancel low-margin orders. It's painful, but it prevents total collapse. You saw this during major disruptions. Medical supplies get priority. Food gets priority. Critical components get priority. The rest waits. A stable system doesn't treat everything equally. It protects the essentials first. That's how stability is maintained under stress. The sixth stabilizer is contracts. Supply chains run on agreements. Who pays for delays? Who owns cargo during transit? What happens if a port closes? Contracts reduce panic. They prevent every disruption from becoming a legal war. They define the rules before stress hits. One famous set of rules is Incoterms. They define responsibility and risk transfer. Who arranges shipping, who pays insurance, when liability shifts. Shared terms reduce disputes. Reduced disputes keep flow moving. Because a supply chain stuck in arguments is a supply chain that stops. The seventh stabilizer is financial plumbing. Supply chains don't just move goods. They move payments, letters of credit, trade finance, and credit lines keep cash flowing. Because when cash stops, goods stop. And when goods stop, everything stops. Finance is the lubricant of the network. Insurance is a huge stabilizer. Cargo insurance absorbs losses. Liability insurance keeps firms operating. Political risk insurance covers disruptions. Insurance turns disasters into costs. And when disasters become costs, they don't always become bankruptcies. That keeps the network alive, even after shocks. Now let's talk about the control centers. Large firms run supply chain war rooms. They monitor disruptions. They coordinate responses. They make fast decisions. It's like air traffic control, but for goods. And during crises, these rooms become the nervous system. They ask constant questions. What's delayed and what can be rerouted? What can be substituted? What can be postponed? Sometimes the fix is switching ports. Sometimes it's switching carriers. Sometimes it's switching materials. Stability comes from improvisation within constraints. Now here's the biggest stabilizer of all, substitution. If part A is missing, can part B work? If supplier X fails, can supplier Y produce something close enough? If a product is flexible, it survives. If it's rigid, it breaks. So resilience often starts in design, not shipping. That's why modern supply chains invest in modular design, standard parts, compatible components, multiple approved materials, multiple qualified suppliers. Design is supply chain strategy. The product can create resilience or fragility. A rigid design turns one missing part into a full shutdown. But let's be honest, sometimes the system does break. If disruption hits too many nodes at once, stability collapses. That's when you get shortages, inflation spikes, and long recovery periods. The network can absorb shocks, but not infinite shocks. So why do global supply chains stay stable most of the time? Because they're built with hidden shock absorbers, redundancy, buffers, standards, data, contracts, insurance, and because humans are constantly managing them, making calls, shifting routes, moving priorities. A supply chain is not a conveyor belt, it's a living system. It adapts, it learns from failure, it adds controls after every crisis. Every breakdown teaches the network what to reinforce next. That's why stability exists at all, not because the world is calm, because the system keeps rebuilding itself to survive the next hit. So next time you see a product on a shelf, remember what you're seeing. You're seeing a global coordination victory, a network that survived weather, politics, congestion, and mistakes. It didn't survive by being perfect. It survived by being resilient enough.